Greetings. In the last 3 video lectures, I have gone over the concept of rational function and discussed a particular example in which the degree of the polynomials in the numerator and denominator were the same. Now, I encourage you to possibly watch those videos if you have not done it already, and in the comment section below I have provided the site link of those videos. I also have some other video lectures in my channel that you are more than welcome to watch and take notes, and hopefully they will be beneficial to you. Now, in this video lecture, I'm going to discuss about rational function in which the degree of numerator is less than the degree of denominator. Okay, then let's get started, shall we? Now, I start with this example, if I may. Sorry for the primitive equipment I have for these videos until hopefully I get better equipment to give more enhanced, but the point is to convey the knowledge. Now, this is an example of a rational function that the degree of numerator is less than the degree of denominator. The degree of numerator of this one is 0. And the degree of the polynomial in the numerator is 0, and the degree of the polynomial in the denominator is 1. It's 0 because you can write 1 as 1 times x to the 0, as x to the 0 equals to what? Equals to 1 as long as x is not 0. And x cannot be 0 anyhow, because 0 is not in the domain of this function. Now, I am going to go over the graph and discuss the graph of that. What happens when x approaches 0, and what happens when x approaches infinity, gets larger. Again, 0 is not in the domain of the function, but as I have mentioned in the previous video lecture, is not in the domain does not mean that we ignore it. In fact, in this case, and in rational function cases, they are of a particular interest, and we call them critical points. Okay, now let me go through example that if we approach that one from towards 0 from right hand side. Now, as we approach towards 0 from right hand side, then the value of the function, which is y, gets larger and larger. Try not to be mechanical. Try not to be make a chart and be kind of junior high school way of doing so. Try to contemplate, concentrate, and try to see the picture in your head, and patiently go with that. Then you will enjoy mathematics. Now here, y, the value of function y, is 1 over x. This 1 over x is the y. So as x gets closer and closer to 0, y gets larger and larger. So make an example in your head. For example, when x is 1/10, 1 over 10, then 1 over 1 over 10 become 10. The mirror image of a mirror image is the object itself. So the inverse of an inverse is the object of itself. So inverse of 1 over 10 is 10. So you are given to x a small value, which is 1 over 10. Y becomes the value of y, which is 1 over x, is 10. So if x is, for example, 1 over 100, then 1 over 100 is 100. So the value of function is 100. So you can see for yourself in your mind, without going through writing a chart or something, as x gets closer and closer to 0, y goes up and up further. And when x is 1, the value of function is 1. as I have put this one. So this will be the graph of the function 1 over x as x approaches 0. Now let's see what happens when x gets larger and larger as a positive selection of positive values for x. So this is as x gets larger and larger toward the infinity. So when x is 1, and as x increases, just put some number in your mind. For example, x is 100. 1 over x is 100th, which is very, very small. So as x gets larger and larger, 1 over gets smaller and smaller, so the horizontal x-axis will become an asymptote. So the value of function gets closer and closer to what? To the horizontal axis as x gets larger and larger. By saying x gets larger and larger, we are the one who select values for x. So we are selecting larger and larger values for x and investigate to see how the value of function will behave. Okay, now let me have the complete graph of that from 0 to where? To infinity in a sense. So that will be the graph of that, complete graph of that in the first quadrant, because the selection of my numbers for x are positive and the value that gives odd, the y value, are also positive, so the graph will land into first quadrant. So that will be the graph of 1 over x, where x is what? Greater than 0. Now, let's see what happens when x is smaller than, less than, to the left of 0. Exactly same. The interpretation is exactly same. But you know one of them, you know many of them. So let's see what happens when we approach x from to the left of origin, to the left of 0. Now, I have already discussed this part of the graph, is that right? Now, here, when x approaches 0, from where? From the left of 0. When x gets closer and closer, but don't forget that the x that you are selecting, the values that you are selecting for x are negative. So when you give negative values to x, 1 over that is also negative. Is that right? Therefore, what is 1 over x? 1 over x is y. Therefore, y will be negative. So x is negative, y is negative, that means the graph will land in the third quadrant. Because in the third quadrant, every point in there, both the x and the y value of that point are what? Both are negative. So we are expecting the graph to fall here. And as we go closer and closer to 0, the value of the function is negative, but gets more and more negative in a sense. The absolute value of that gets larger and larger, so the function goes down further. Again, you can put few numbers in your head and see, look at that, contemplate and look at it and see what happens. And exactly same happens when we go toward left, which means that the numbers that we select for the x are negatives. So when we select, we notice that the value of function gets closer and closer to the horizontal x-axis, but always negative, because we are selecting negative values for x. Numerator is always positive. 1 does not change its value, it's a constant. So if the numerator is always positive, denominator x that we are selecting for that are negative, therefore the y value will be negative. Therefore the graph will land into the third quadrant. I'm repeating myself. Okay, then now let's look at different scenario. So This is the good picture, hopefully you can always pause and take notes. But the best is, again, I repeat myself, do not become mechanical, do not be recipe followers, try to contemplate, improve your critical thinking, and always be kind of critical in thinking. Do not take anything for granted. Okay, now what happens if we have this kind of scenario, which is negative 1 over x? In that case, what is this negative? This means the value of function will be what? Will be negative, is that right? But, will be negative if x is positive. But if x is negative, then this negative makes it what? Positive. That's exactly what the definition of absolute value is. This is also a good review for that. So if I'm selecting my values for x to the right of 0, as I have already gone over the graph of that, so the x that I'm selecting values for, the values that I'm selecting for x are positive, this makes it negative. So that means x is positive, y is negative, my graph will land into the fourth quadrant. Because in the fourth quadrant, x is positive, y is negative. You follow me? Okay, then what happens if I'm selecting the values for my x negative to the left of 0? Those numbers that I select, this negative makes it positive. Means, what is that? This positive, but this is y. So the y will be positive. So the selection of my x are negative, the outcome of that, which is y value, the values for y are positive, therefore the graph will land into the second quadrant. Because in the second quadrant, x are negative, the values of x, and the values of y are positive. So the graph of that is very similar to the previous one, but in the second quadrant will go like this, and in the fourth quadrant will go like that. And hopefully you have the picture in your head. You don't have to go and sketch it. Improve your imagination. All right? Now, let's take all the possibilities for the under consideration. Let's see what happens if we have different kind of values for that. So, let's see what happens in that case. Now, I'm putting a general form of that, and that is y equals to k1 plus k2 over x to the power of n. We are dealing with polynomial, therefore we know that n is a non-negative integer, 0 or positive, and k1, k2, k3 are all constant. And we know what constant means. The value of them stays same, does not change. So we want to know what is the effect of this constant, and this constant to the graph, and also what happens if the n changes, the degree of the polynomial in the denominator, let's say, increases from 1 to 2 to 3 and so on and so forth. All right, now let's start first with this one, which means we go to K2, the constant in the numerator. Now, what is the effect of that one? Now, the constant is a number, and a number can be positive, negative, and 0. So we are not concerned about 0 is a trivial. Now, if k is positive, then depends on if k is between 0 and 1, the selection, or k is bigger than 1. If it is 1, we already have discussed it. Now, if k is between 0 and 1, k is what? Is a factor. Because we can write, this one we can write it k2 times 1 over x. So k2 is a factor. So if it is bigger than 1, what happens? The graph of this one, when we go towards 0, goes up a bit faster, depending on the value of k. The bigger k is, the kind of faster it goes up. Okay, I'm selecting my k bigger than 1. And when I go to the right, since k is bigger than 1, it will go toward the asymptote, but a little bit but slower than previous one, which was 1 over k, because my k2 is bigger than 1. So you have a good picture of yourself how the graph will look like for different values of k and k2. And if k2 is between 0 and 1, then goes up a little bit slower and goes down a little bit kind of faster toward what? Toward the horizontal asymptote. And you know the other side of it. What happens if k is negative? We already discussed negative 1 over x. And if k2 is negative, very similar to what we were talking about. So hopefully you have a good picture in your head. Now, let's see what happens to this one if we are talking about k1 now. What is the effect of k1 on the graph? Now, we want to know what is the effect of k1. Okay, then let's see what happens. What k1 will have effect on what? On our of the graph of our function. Now, k1 is a constant. Is that right? It still remains the same. So the effect of that is that it doesn't distort, or it doesn't change the graph of 1 over x. The graph of 1 over x remains the same. The k1 will take it either up or down depending if k is positive or negative. So if k1 is negative, this graph will take it without distorting, without moving any other direction, without making that skinnier or more fat. The way it is, we move it, if it is positive with respect to this k1, whatever it is, if it is, for example, 2, this graph will move 2 units up. And that is same as if you take the horizontal axis for this one, move it 2 units down. Same effect, huh? So we know what will be the effect of k1, which is a constant. I'm repeating myself. Now let's see what happens the effect of k1 and k2 combined together, what will have the effect. Now we are looking at the scenario that investigating the effect of k1 and k2 together to the graph of our function. Let's see what happens. Now, we already know what happens to the graph of when k2 is positive or negative. It does not preserve the graph of 1 over x. It makes it either a little bit skinnier or a little bit fatter in a sense, depending on the value of k2, if it is bigger than 1 or if it is between 0 and 1. We already investigate that one. Once k2 is selected and the graph is either it is a little bit skinnier or a little bit fat of 1 over x, then k1 comes into the picture. Then k1 will take that graph and without distorting it, move it up and down with respect to what? With respect to what? The value of k1. Now, we also know what happens if k2 is negative. We already also investigate that. So the possibilities are k2 is bigger than 1 or between 0 and 1. And if k2 is positive or negative, that's possibilities. And the possibilities for k1 is either positive or negative, goes up or down. Okay then, so we are comfortable with this one. Now let's see what happens if the degree of our polynomial kind of changes. Now from the original one that we started with, the degree of that was 1. Let's see what happens if n is 2. So let's talk about that scenario. So if the degree of the polynomial in this case is denominator is even, is 2, the denominator, no matter what value you assign for x, of course besides 0, denominator is always what? Always positive, as long as it is 2 or 4 or 6 and so on and so forth. Huh? So that means the value of the function will always be positive. So if the value of function is positive, but selection of values for x can be positive or negative, that means the graph, the sketch of the graph must fall into first and second quadrant. Again, you are not becoming mechanical and following recipe, but you are contemplating, thinking, and improving your critical thinking. This is always positive, therefore y is always positive, and y is positive in first and second quadrant, but x can be negative, x can be positive, because our selection can be for x positive to the right of 0, or selection of values for x will be numbers to the left of 0. In either case, the graph will fall into what? First and second quadrant. In the first quadrant will be very similar to 1 over x, very similar to that, but when you go closer to the 0, it goes what? It goes 1 over that. When you square it, gets smaller. Is that right? And 1 over that gets larger, so it goes up faster. And opposite of that happens when you go toward infinity, because x squared become much bigger, therefore the fraction 1 over that gets smaller. So the graph goes toward the horizontal axis in a sense much faster. Okay, then we are familiar with this one. Now let's see what happens if that is negative instead of that. That's a good observation to make. That's another kind of scenario. We are taking all the possibilities. Now Kn is 2, is that right? And the coefficient, which is K2, is going to be negative 1. Let's see what happens in that case. Now here again, the x squared, the values that we select for x to the right of 0 or to the left of 0 are going to no effect. The x squared makes it always positive. So this is always a positive number. Is that right? Now this negative makes it always negative. But what is that? All this is y. Therefore y will be always negative regardless of the selection of our number for the values for x. So if we select x positive or we select x negative, the value of y will always remain negative. That means the graph must fall into third and fourth, depending on the selection of x, third or fourth quadrant. Because in these two quadrants, y is negative. But again, selection of our x will be the values that we select for x will be, we can select positive or we can select negative. Okay, then now let me go also. One thing important to mention is about the inverse of that, and I'm going to take the graph of that and see how the inverse of that will look like. Now, toward the beginners, they always think that 1 over, this notation is adapted for representing inverse function. And we already know all of this stuff. The function must be 1 to 1 and onto in order to have inverse, and its inverse will be a function. And in this case, the function is 1 to 1 and onto in a sense. Therefore, what? Therefore, the graph of that will be, the inverse of that graph we can investigate if we are talking about one side of it. Now, here, this negative 1 over x does not mean x over 1. This negative over that means the inverse of that. And to get the inverse of that, let me see if I have the graph of that and see what the inverse of that will look like. I have gone over this subject in detail, rotation and reflection, and I do encourage you to watch that video. There is a lot of good knowledge for the beginner, why it works geometrically and also analytically I have explained. Now, if you rotate this one 90 degree and then reflect it, you will see this graph, and that is the inverse of the previous one. Again, let me go one more time. If where is my function? This is the original function. Is that right? Now, rotate this one with respect to the origin. Rotate it 90 degrees clockwise or counterclockwise. I do rotate that. Then reflect it. Now, what you see is the graph of the inverse of that. The asymptote has changed, but in this case, the asymptote, both of them are what x horizontal asymptote, so you can see the no is the vertical in a sense asymptote, and the horizontal asymptote because the y-axis. Do you follow that? This is the inverse of that. All right then, I thank you for watching. I hope that the contents of this video was beneficial to you, and I wish you all prosperity. And thank you for watching again for a second time, and please stay safe. So long.